Hi, I'm Umi, and I am going to explain problem 2 of section 7.2. So problem 2 states, write arctan x equals 1 times arctan x to find the integral of arctan x dx. So first, let's see what the problem is asking for. So it seems that what we're looking for is the integral of arctan x dx. So let's write that. The integral of, and I prefer to say tan inverse of x dx. Maybe it's the influence of Mr. Seamon. And then we have to see what that's equal to. So you might be a little confused about this and not immediately see what method you have to use for integrating. So let's do what the problem suggests. Write arctan x equals 1 times arctan x. It seems kind of pointless, but since the book is explicitly stating it, it might be useful, so let's try it. Okay, so the integral of tan inverse of x dx equals the integral of 1 times tan inverse of x dx. Okay, so that looks basically the same, right? Well, not exactly, because now we can see clearly that there are two parts of the expression being multiplied. So, what does that remind you of? Hopefully, it reminds you of integration by parts, which is what we have to use to solve this problem. You might have also guessed that we were going to use integration by parts because that was the subject of Chapter 7. Anyway, to use integration by parts, we have to identify u and v prime in this integral here. So, let's see. Either u or v prime is 1 and the other is tan inverse of x. So let's think about strategies for determining which is which. So we know that usually it's better when u prime is simpler than u. So that would be the case for either of these. If u were 1, then u prime would be 0, which is pretty easy to work with. But then we're left with tan inverse of x, which would leave us with a problem, because if v prime were tan inverse of x, then we would not know how to solve for v, because we don't know the integral of tan inverse of x. We are trying to solve for the integral of tan inverse of x, so including that in the solution would be very pointless and defeat the purpose of the problem. So I hope I have convinced you to use u equals tan inverse of x and v prime equals 1. Okay, so now we know u and v prime in the original integral. Let's find u prime and v, which I promise will come in handy later. So, since u is tan inverse of x, u prime would equal 1 over 1 plus x squared dx. That's just something you should memorize. If you haven't, shame on you. Okay, so now we have v prime equals 1. So to find an antiderivative, we have to integrate. So I hope you know that the integral of 1 is x, since we're doing this in terms of x. Oh, and I should add a dx after 1 in v prime. Okay, so now we have all the information we need to write the equation that will allow us to solve for tan inverse of x, or to solve tan inverse of x. Okay, so we have the fundamental or like general formula for integration by parts, which is the integral of uv prime dx equals uv minus the integral of u prime v dx. Okay, so now we just have to plug things in, right? So we're given all four of these functions above. So let's just say the integral of u, which is tan inverse of x, and v prime, which is 1. So let's just let that be. Dx equals, and then u and v, tan inverse of x. I'm going to put the x in front because it looks prettier, minus the integral of u prime, which is 1 over 1 plus x squared, times v, which is again 1, so we don't have to include it, dx. Okay, so now we have an equation, and we just have to solve this integral here, because since we're solving an integral, it would be really pointless to have an integral in the solution. The point is to have no integrals. Okay, so let's think about strategies for solving this integral. Well, oh my gosh, I made this mistake in my last attempt on this video as well. Why am I so stupid? Okay, anyways, I forgot to do one thing, which was to multiply u prime by v in this most recent version. So here you can maybe see that this 1 is actually not a 1, it's an x, because that is what v is. V prime is 1. Please don't make this mistake. Okay, well, I mean, I'm sure that you recognized that I made a mistake. I was doing it as a test of your intelligence to make sure that you were paying attention. Okay, back to the problem. So I'm just going to rewrite the integral because it became kind of messy. So the integral of x over 1 plus x squared dx. All right. So let's think about strategies for solving this. Once again, we can't really just know what the integral is because it's not a single term. So maybe we can use U-substitution, since the numerators and denominators degrees differ by 1. So let's see. It would be logical to say that u would equal 1 plus x squared, since that is the higher power in the expression. So in that case, du would equal 2x dx, simple differentiation. So now let's just isolate x dx, because we know that that's what goes in the problem here. So then 1/2 du equals x dx. All right, so now let's try to substitute x with u. So then the integral of, and then we know that x dx up here is 1/2, or no, x dx is 1/2 du, yeah. So let's just say du, and then I'll put the 1/2 outside of the integral so that it's prettier, and then divide that by 1 plus x squared, which conveniently is equal to u. So this is a manageable integral, right? We know that the integral of 1 over u would be ln of absolute value of u plus c, and then we have to multiply that by 1/2 because that's outside the integral. And now we can just replace u with 1 plus x squared because we need x for the other equation that we'll return to shortly. And since we know that x squared is always positive and 1 is a constant, we can just say that that is equal to 1/2 times 1 plus x squared plus c. Okay, so we're making good progress. So now that we know what this integral is, we can just substitute it in. So the integral of tan inverse of x dx equals x tan inverse of x minus 1/2 times 1 plus x squared. Oh, oops. 1/2 times ln of 1 plus x squared plus c. And that is our final equation. I forgot to put in ln here also. I'm sorry, I'm a terrible person. And also here. But this is what we're left with. This is the whole problem. I hope that you found it educational, and I want to do something creative, so I am going to draw a bunny as a thank you for watching my video and hopefully not falling asleep. Okay. Wait. Alright, I guess